All right, so today we're going to finish up lesson 9-1, where we're going to talk about solving by the completing the square method. So you're going to learn another way to do quadratics by using this completing the square. So we're going to use the same note sheet as yesterday that I posted in Google Classroom. Let's go ahead and get started. Okay, so to complete the square means that we're going to add in another term so that way we can get a perfect square trinomial. Okay, which allows us to factor and look like, so this is a perfect square trinomial because when we factor it, we get the same factors, x plus 3 times x plus 3, which we could rewrite as x plus 3 squared and square root both sides like we did in yesterday's video. Okay, so in order to complete the square, we need to figure out what number we need to include in the problem in order to get that perfect square trinomial here. So this plus 9 that we included in. Okay, so if we're looking at our basic form for a quadratic, ax squared plus bx plus c, the way you find the number that completes the square is by this formula. You take half of the b term, so b over 2, and you square it. So if you remember, completing the square uses this formula because you're going to have a little square in the problem. So how they got the 9, so in step 2, find the number that completes the square. They took half of their middle term, so half of 6, which is 3, and squared it. So that's how they have plus 9 here. Now we can't just add a number into a problem without balancing it on the other side. So we're always going to, whatever we add in on the left, we add the same amount on the right. And then we clean it up, and we can use square root method then to factor it. Okay. All right, so let's look at 1. Now this is the only problem type where we don't want it equal to 0. So when we factored and when we did all the other problems, we always wanted it equal to 0 on the right side. This is the only one where we don't want that to happen. So all of these problems, what we're going to do is we're going to take our constant and move it to the other side. So I'm going to take this 15 and move it over like this. So we're going to have x squared plus a 2x. Now I'm going to leave a plus a blank because we're going to complete the square. Is equal to 15 plus blank. Okay? Because again, whatever I added on the left, I have to balance it on the right side and keep it equivalent and add that same number in. Okay, so to find the number that completes the square, I'm going to take my b term, so my middle term, so 2, and I'm going to cut it in half, so 2 divided by 2, and then we square it. So half of 2 is 1, 1 squared is 1. So the number that completes the square for this problem is 1. So if I add that in, I add that in. Okay. Now what I have to do is take this left side and we're going to factor it out. But it's going to factor to be a perfect square trinomial, meaning it's going to be something squared. So if I do this, I would need factors of 1 that add to 2. Well, 1 times 1 is 1, and 1 plus 1 is 2. That's why it gives us this quantity squared part, because this is technically x plus 1 times x plus 1, or x plus 1 squared. Okay. Equal to, on the right side, I have 15 plus 1, which is 16. Okay, so now to undo that square, we do like what we did in last night's video, and we square root both sides. So I'm going to get x plus 1 is equal to, remember, we can't forget that it's plus or minus 4. So we're going to get our two solutions here. We're going to have x plus 1 equal to positive 4. And we're also going to have x plus 1 equal to negative 4. So when I solve this, I just subtract 1 from each side. So 4 minus 1 is 3. Negative 4 minus 1 is negative 5. So there is our two solutions. Okay. Now there's patterns here. Okay. When we do this quantity squared thing, we don't necessarily have to factor it every time if you remember the pattern. It's always going to be half the middle term, so x plus half the middle term. And it's always going to be the same sign. So since this one's a plus, our factor will have a plus in it. But Let's do another one, and we'll talk about the patterns a little bit more in this one. So the constant is already moved to the other side, so that's good. So all we have to do now is complete the square. So I'm going to take x squared plus 6x plus a blank is equal to 15. And again, whatever I added on the left, I have to balance it on the right, so plus a blank. So to find the value that completes the square, we take our middle term and we cut it in half. So half of our b term, and then we square it. So half of 6 is 3. 3 squared is 9. So plus 9 plus 9. Okay? So now this part here, technically what we're doing is factoring it. So you can set up your x if you want and factor it, but let me show you a little pattern. So it's always going to be x plus or minus something squared. Now, whatever the sign is in the middle term in the problem, so whatever the sign is here, it'll be the same sign in there. Okay. What goes in the parentheses is always half of the middle term, so it's going to be 3. Because 3 times 3 is 9, 3 plus 3 is 6. So it'll always have that pattern. Okay. Now we just have to add these on the next one. So 15 plus 9, that should be 24. Okay. All right, so now we are ready. We can square root both sides, but I can already tell this isn't going to work out too nice because 24 is not a perfect square. That's okay. Let me show you what happens if it's not a perfect square. We're going to get x plus 3, the squared canceled with the square root. And we have the square root of 24, which technically we could reduce. Let me rewrite this. So a radical, we can break this radical down into two numbers. So factors of 24 could be 4 and 6. Since 4 is a perfect square, we could square root that. So we'd get a 2 on the outside, root 6 stuck in the inside. So we can't forget our plus or minus, which I almost did. But if I subtract 3 on both sides here, we're going to get plus or minus 2 root 6 minus 3. Now this 3 doesn't have a radical, so we technically cannot add or subtract these. It's going to be left just like this. So you have plus or minus 2 root 6, which again I got from reducing the radical of 24. And then I just subtract the 3 over to get x by itself, and I'm done. Okay. So you guys are going to try one. You're going to do on your own a. So x squared minus 2x minus 63 is equal to 0. So let me help you out first. We're going to start by moving that 63 to the other side. So this is going to be kind of your setup. If I add 63 over, here's kind of what we have. So it's going to be x squared minus 2x plus a blank is equal to 63 plus blank. Whatever you add in to complete the square, make sure you balance it on the right side of the equation as well. Okay, so give it a try. See if you can solve this one. It should work out to be a perfect square number, so you shouldn't have to do any weird radical stuff, but give it a try here. Take a second here and try it. Okay, the two answers I got were 9 and -7. So let me show you my work. I'm going to pull it out here on the side. So I have my setup, and I complete the square by taking half of 2, which is 1, and squaring it. So 1 squared is 1. So we add 1 to both sides of the equation. Now my parentheses, it's x. And remember I told you it's always the same sign. So this is minus. This is minus. Okay. And it's always half the middle term going in the parenthesis, because 1 times 1 is 1. 1 plus 1 is 2. Okay. Square root both sides, so we get plus or minus 8 on the right, and then I set up my two equations, so positive 9 and -7. Okay. So completing the square isn't always the nicest one to use. Sometimes factoring is better, in my opinion. It's faster, but this is just another way to solve quadratics if factoring is not an option or if factoring is not your first choice. So it's just another method that we can use.